Alright, inverse. So first, we know what inverse is. Like, if you're trying to solve for theta, you use like sine inverse or like tan inverse, whatever. Um, so let's take this for an example. Y equals 3x squared. We can envision this. We know what it looks like. To get the inverse of this function, all you do is literally just whoop, whoop. Wow. It's x equals 3y squared. That's the inverse. So now, to see what the function actually is, you have to solve for y. I cancel out the 3 there, and then y squared is going to be equal to x over 3, square root both sides, and you'll get that y is equal to plus or minus x root x over 3. Let's just get this a little bit more tidy. So yeah. But just because you're taking the inverse of a function doesn't mean the inverse will be a function. As we can see, one x value can actually bring us two y values due to the plus or minus. So that would fail the vertical line test. So if the inverse of a function is just you flipping x and y in the entire equation, you can do the same thing with the values, like right here. X here is -3. We're going to take the inverse. Now y is -3. They have swapped places, just like how we did in the function. Same thing for the rest of the list. 2, 2, and then 2, 6. Now, if we graph this, it looks like that. Now, when you look closer, you might not notice it right away, but the line of reflection here is this. And don't worry, I'll show if you're confused by why it's that. I'll like flip the image and stuff. But yeah, this is the line of reflection. Now, obviously, a completely straight line that looks like this, the equation for it would be y equals x. We know what y equals x looks like. Alright, so turns out MS Paint is really bad for videos, might switch. But you look closer, if you tilt your head a little bit, and if you look at it, you can see that these two lines are just kind of mirrors of each other through that line. So that's why we say that the line of symmetry is y equals x, because it's literally, if it was a mirror, that's what it would look like. So what is the domain and range before and after the inverse? So let's see for the original one, right? Let's x -3 x 6 x e r. Here's what happens, right? Once you inverse the function, the domain and range switch. So the range for this is 0 must be lesser than or equal to y, must be lesser than or equal to 3. That becomes the domain. So now we have the domain become 0 must be 3. Let's get some more space here. X, E, R. Alright, so x is going to be equal to y squared. Isolate y equals root x plus or minus. Okay, so square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and then, plus or minus, put that down there. Now, once again, the line of symmetry is y equals x, as we can see. Varying points are on the line of reflection, and that looks like 1, 1, and 0, 0. So 0, 0, 1, 1, which makes sense because if we're swapping x and y values, swapping 1 and 1 doesn't really change much. Now, what's the domain and range before and after? Let's do that. So d r, and then for after d r. Okay, so let's just do this. So all we do is just switch it, and yeah. Now let's see if this inverse is a function. And no, it is not. Now you can see if the inverse is going to be a function or not by just doing a horizontal line test on the original. See? This passes through twice, which means the inverse of that function will not be a function. Because, you know, if we get the inverse of this, that's gonna happen. Now we can fix this by restricting it. There's many ways to restrict it. You could say, hey, x must be greater than 0, which just completely removes this part of the original graph. And then, considering the line of symmetry, the inverse of this new line would look like this. You could do x must be lesser than 0, removing this, which results in it looking something like this. So if the inverse is a function, then we can use function notation for the inverse, which looks like this. Alright, so first things first, let's get the equation for the inverse. So x will be equal to 4y minus 2. Solve for what y is equal to, and you'll get that sorry for the imperfect graph. So because this is the inverse of the original function, we can just say that f negative 1x is equal to what this is. 1 over 4x over and plus 1 over 2. And the mapping notation, it's just the y and x values swapped. Will the inverse of this function be a function? Nope, it just failed a horizontal line test. No. Draw the inverse, let's do it. Our line of reflection. We can restrict it by saying, you know, x must be greater than 0, which just eliminates this entire part. You can pause here, try and do this on your own. So first, y is equal to 4x minus 2. Swap the values. X equals 4y minus 2. X plus 2 over 4 equals y. Y is equal to 1 over 4x plus 1 half. So since this is the inverse of the original function, we can say that f negative 1x is equal to 1 over 4x plus 1 half. Now this question, what does this actually mean? Well, we already found f inverse right here. So when they replace the x with f of x, all that means is for every x in the inverse, you're gonna replace it with f of x. So what that's gonna look like is f inverse for x minus 2, right? Because that's our f of x. Okay, so that's gonna be equal to 1 over 4, and instead of x, we take this, 4x minus 2 plus 1 over 2. Okay, so let's keep going. 1 over 4 times 4 is 1, so that's just going to become x. 1 over 4 times negative 2 is negative 1 half. And we're left with these canceling out, leaving us with just x.